Hi everyone. My name is Lode. We're going to start with a video to get you all in the right mood. A little bit of nostalgia of old data carriers. So now if you push next one to play, then if it doesn't play, I'm sorry, it's an old video from the Zip commercial, which is basically saying that you can store everything on a 100 megabyte zip drive. I will send the link from YouTube in the WhatsApp group because apparently it doesn't really work from YouTube. So I'll start with just introducing ourselves and our organization. This is all our colleagues at Memo, and those two arrows. Oh, excuse me. The little arrows is me, and then on the right side is Nastasia. And our colleagues at Memo, we provide advice and practical support to cultural media and government organizations which take care for their archives. And we aim to make archival materials accessible and usable, and we also preserve it for the future. So that was our complete team, but Nastasia and I are part of the expertise team. And all the people in the circles on these pictures are also part of our expertise team. So we share our acquired expertise on digital heritage processes with other organizations, for example, by responding to requests for advice, organizing training sessions, setting up projects, and providing information through presentations like this one and our knowledge base. So the service we're going to talk about today is called the AIDA Capture Lab. It was previously known as the Digital Repair Cafe. And it's a service we provide at Memo to retrieve information from outdated data carriers. We call them outdated data carriers because they're not able to be read anymore by modern computers readily available. For example, the reading equipment is no longer available in stores, or because modern computers are not longer available, have the ability to read the equipment. This is an overview of the data carriers we can capture at the moment. So from old to semi-recent, 2005. The old one is 1976. So we start with the mini floppy, micro floppy, and we go to the DDS tape, the zip disk, the jazz disks, and then to the micro SD card. And also like the hard drives and stuff.
So AIDA Capture Lab is a service of AIDA, and AIDA is a collaboration between 7 organizations, of which are 5 archive institutions. We decided to work together to improve the care of the digital archives. And AIDA Capture Lab is a result of a project called Digital Repair Cafe, and which had the aim to set up a service for reading data of obsolete carriers. So why did we start this project? Because every heritage institutions, from large museums to little small local history societies, are confronted with this type of material, and it's impossible for all of them to set up a service like this. So it requires specific knowledge about the drives and the disks, and also the devices we use are rare, so it's not easy for all these organizations to find the devices themselves. It requires also money, because the devices are sometimes rare and thus expensive. So it was a better idea to work together, to combine all our budgets, and to buy these together. The service is operated by Memo, our organization, because we already had expertise on this topic. We experimented with these materials since 2017. So that's why we do the service. So our goal is to save the entire content of an obsolete disk and save it on modern media. So the goal is that the captured content of the disk is identical to the original disk, and it's fun. It's nice if the content could also be consulted. It's not always possible because sometimes disks are damaged and then they can be mounted and you can't consult the files, or sometimes the media is obsolete and you don't have computers that can open them, and then emulation is required. So we do this by creating disk images. Disk image is an identical copy in a digital file that is identical to the disk. We chose this method for several reasons. Because it's not always possible to mount the disks with the computer because it's obsolete, but also it gives us more guarantees that the transfer went correctly. And also there isn't a risk of a lot of metadata because sometimes there's also metadata in the file system that is necessary, like for example the last modified date, the owner of the file, but also old Macintosh disks that didn't have a file extension. So this information was kept in the file system, and if you lose this information, it's difficult to know what files you have in the copy. We have 4 setups to create a disk image, and I'm going to go over them now. So this is the general one. We call them the general because it's the setup that's suited for most of our devices. You can use them for devices from the mid-90s until now. It consists of 4 components. So the first one is the original drive. So this is on the slide you see a zip and a jazz disk, and that's an original jazz drive. The second component is the cable or an adapter cable. So jazz disk had SCSI interfaces, and our modern computer has USB interface. So we need to look for a cable that could, a SCSI to USB cable. So what you see on this slide is a very expensive cable. Then the third component is a write blocker. A write blocker takes care that the computer doesn't write on the original disk, so it stops the write command of the computer. So this is the write blocker more in detail. It's one of Tableau we use. There are other brands. And the fourth component is our workstation with forensic software. We use this software to create a disk image, but also to get the files of the disk image. And as forensic software, we use the Bitcurator environment. It's a specialized Linux version. It's free and open source, and it's created by universities and other organizations that preserve digital archives. So this is the software you use for creating disk images. It's called Keymager. It's a Linux software, open source. It takes care. It makes checksum to make sure that the copy is identical to the original disk. Then the second workflow is our workflow for floppies. It's a different setup because the data is stored differently on floppies. It are magnetic signals, like radio signals, and you need an interpreter that translates these magnetic signals to computer data. And there are simply no USB devices for all diskettes or floppies, so you always need something between the floppy disk and your computer. We use CryoFlux to do that. So this is a device that can control the floppy drive to get the data from the floppy. This is the CryoFlux software, and this is the interpreter. So it translates these magnetic signals and it creates a disk image of the magnetic data. And this is our third setup. It's a setup for tapes, because also on tapes, files are stored differently. They are stored sequentially, like on an audio tape or an audio CD. So files are written as tracks. So you have an archive file per track. And we use Tape Imager to create images of tapes. Tape Imager is also open source software. It's created by Johan van der Knijf. He works at the Dutch Royal Library, and it creates an image per track. So you have different images of each track. When it has viewed the last track, it rewinds the tape, and then it ejects the tape. So the tape workflow is a bit different because you have different images per track, and it's not a complete copy of the of the disk of the carrier. So you then have to find out what the software was that created the track. So if you're lucky, it's a tar file. It's a file that we still use, that you still can open, but if you're unlucky, it could be created with old backup software from the 90s that no longer exists, and then it becomes a challenge to get the files out of the image. And we use Siegfried for file identification. So when this is a fourth setup, Lode?
So the hard disk is quite easy, so we can read them individually or for the time. In some cases, the visitors for the AIDA Capture Lab don't need a whole disk, including the empty space. So there's no need to create a disk image. We prefer it, but we can do it with AirSync to keep the original modified date, and then we prevent the larger disk image. For exporting the files from the disk image, there's again some solutions on the bit curator system. In this case, I think it's the HiveS Explorer. And we haven't really worked out manuals for exporting data from disk images yet, but it's certainly possible and we can do it. This is an example of a disk image that was not able to be exported with the provided software, and so we opted for the emulation instead. In this case, this is the emulation for Apple System 1, and the first Apple Macintosh system released in 1984. The files on the disk turned out to be made with Aldus PageMaker 3, the predecessor of Adobe PageMaker and now InDesign. We know this from metadata of the disk image. So what happens when a new carrier comes at the AIDA Capture Lab? We go through a very simple steps. So can we identify the driver, the carrier? Nice, we have a little handy guide for that. It's called Identifying Obsolete Carriers. If we can't really identify the carrier, we just Google, we go to obsoletemedia.org and Wikipedia. Do we have a reader for it? Nice. And if we don't, then we keep it a little aside, and then we wait for a little budget, and we go on eBay and search, and we hunt for the reader. Then the cables, it's a bit difficult sometimes. You saw our Adaptec cable from SCSI to USB. That was a nice find. The carrier, if it's damaged, then it's basically useless. If it's not, then we can continue down the road. Does the media work with the write blocker? So you saw in the examples, the write blocker is between the reader and the computer. Sometimes some drives don't really like the write blocker, and then we take it out of the equation, and we are very careful, and then we don't use the write blocker, and we continue. Can we make a disk image? Really nice, that's what we prefer. And if it's not possible, then we troubleshoot or give up, but that rarely happens. Can we read the files on the disk? All right. If not, we do some troubleshooting and we try some emulation. Maybe that's an option. So talking about those challenges, coming from the late 90s, I was really overwhelmed by the amount of SCSI that was out there, and pins and terminators and gender changers. So I was a bit overwhelmed to see, but apparently it works really fast. We had like a nice image, and we could continue from that. Counting the pins, cannot remember how many times we counted pins on connectors to know what kind of SCSI it was. I'm glad we are at USB. The other challenges are finding the right drives. For sure, to order them online. Sometimes they come from America, and then we pray that it arrives we hope that it arrives in one piece. The test material sometimes is difficult because you don't want to test your setup with the precious archive object, and sometimes blank versions are included, for instance with the MO drives, so we can test with those. But we always look for test materials from other archives. The damaged carriers is also quite challenging. It's hard to give up and say, okay, we can't read it, we tried. There's some old issues that come back, namely the click of death. This is a particularly dangerous one for the zip drives from iOmega, in which a damaged carrier could damage the drive, and that drive could continuously damage new carriers. They're also very susceptible, vulnerable to magnetic radiation and dust because of the design. The software updates are quite nerve-wracking sometimes because our bit curator system is really nice as it is, and we installed some extra software on it that required a lot of time to get working with the specific dependencies. It's also based on Ubuntu, so we have to get some extra dependencies sometimes. In the case of the floppies, the obsolete software is a little bit of a challenge in the sense that you have to know beforehand how the floppy was written. In the case of Apple DOS, you have to know it and then to tell the system how to interpret the data. And to solve the problems with outdated file formats, we try to make the data accessible. If anybody can help us with any of these 8-inch floppy drives, compact floppy, Travan, and SideQuest, contact us, please, especially the 8-inch floppy. And if you want to know more, you can go there. Thank you.
Thank you very much, Nastasia and Lode. Do we have questions from the audience? We do.
Hi, that was fantastic. I have a question about the CryoFlux, because we were looking into buying one recently, and it's quite cheap, but found that the pro software, once they realize you're an institution, is like €5,000. And I'm wondering, has that always been the case? Have they just skyrocketed their prices recently? Or has everyone run into this where the hardware's fine and the software is like practically impossible?
We use it already a long time, but for us it was just having the hardware and then we could download the software for free, actually.
We will send you a copy.
It was in the past it was different. You could get the CryoFlux, the hardware, you could get cheaper if you were a particular person, and it was more expensive if you're an organization, but the software was free then. But we speak about 2017.
Yeah, I have a comment on this. So they're existing an open source version. It's called Pauline from MO5. It was developed for game preservation, and it's like the same as CryoFlux, but all is open source.
Okay, thank you.
And it works for all, for 8-inch, 5.25, and 3.5-inch floppies. So I use it and it works perfectly.
Okay, thank you. We'll see you in the break.
Yeah. It calls Pauline, also Pauline.
Okay, thank you.
Okay, thank you.
I have a question according to the using of the Tableau forensic bridges. And there are existing a lot of different bridges, also from other vendors with different adapters and cables. And I saw that you're using, for example, the SATA to USB devices and then connecting it to via USB with the USB Tableau forensic bridge. But there was also a picture where you connect it directly with the SATA adapter. Did you recognize the difference if you're using an adapter or not?
No, not really. We only opt. Yeah, no, not really. Sorry.
Okay, thank you.
We've got another question.
Hi, thank you. I was just wondering about if you had any sense of when you're not using the right blocker on some of these transfers, if you noticed a big time change, like if the right blocker was adding a lot of time for transferring the files, and which formats that related to.
So we don't really work with hard drives larger than a couple terabytes, and even then we don't really use the white blocker a lot. So luckily the old data carriers are quite like small capacity, so we don't really notice any speed difference. Anything else?
Okay. But we also didn't measure it, so it could be that there's a time lag.
I'm afraid that you having the big budget do like that.
Excuse me, we had 1,700 euros 1 year, so it's not a big budget.
Because what we do is keeping the old device, including old computers, and what you show is quite new. We're dealing with the Apple II diskette, which is 5-inch, and as well the big one from, I don't know how it's named in the West, 8-inch diskettes, you know. And this is yet not so hard to keep them, because a lot of people made based on mostly Arduino and Raspberry Pi readers from the diskettes drive that is still you can find in the market. I talk about old diskette drive, which is 5-inch. And they convert, and you can get from the card, from the storage, or directly from the network. And this is best way. It means that we have a cross network of Apple II, Commodore, and things like that. That still can read from the diskettes or drives and transfer to the more current computers. As well, I think that DD command on Linux is very good. You can get older version of Linux that support DDS and JAS and zip and optical. You know, there was optical magnetical, if you remember, drive. And this is just a kind of comment and kind of suggestion that you may find another way to deal with that, which is more, I don't know how to say, cheaper and more less trouble and less working. So where you get money, by the way, for this project?
Do you want to?
It was funded by the Flemish government. Thank you.
Thank you for the question. It was enriching for everybody.
No. Only no punch cards. That's all. So.
Okay, thank you, Nastasia and Lode. We've got not much time left. So thank you very much for your presentation.